All right, chapter 3, section 4. Shouldn't be too tough today. It's a couple more theorems to deal with. Again, these are theorems, so that they don't have to be proven. They can be proven, but they're based off of some pretty basic properties and postulates. And as a result of that, we just take them as fact because they are provable, but they do put two and two together, right? So linear pair perpendicular theorem, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Okay, so in other words, two lines that intersect and this side is equal to the other side. The only way that would happen is if they were perpendicular. That's what they're trying to say. Perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it is the other one. Okay? So one more time here. If we have two parallel lines and we get a transversal and it's it's perpendicular to the first parallel line and we don't know about the other one, we do because according to the perpendicular transversal theorem, if it's perpendicular to one, it's perpendicular to all of the lines that are parallel. Finally, lines perpendicular to a transversal theorem. See how they're very similar? They kind of confuse you, but use your notes. If two lines are perpendicular to the same line, then they're parallel. So it's the same idea here, right? If we got a line, we got two different lines coming across. It's perpendicular, perpendicular. It's two lines perpendicular to the same line. That's the situation we're talking about here. Then we can conclude it's parallel. Okay. Now, for our work today, a lot of it's going to have to do with the distance formula. Okay. So you're going to have to graph. You're going to have to use the distance formula. Here's an example. What are the distance between A and this line right here? Obviously, it comes straight down at the perpendicular. That's this point right here. So therefore, despite all this information, the only information we need is this distance right here. We plug in our x1, y1, x2, y2 into the proper information here. And when we do that, we get our distance, which is about the square root of 32. Now, there are no parallel lines. Okay, so that's good. All right, so that's our answer. Next, determine which lines, if any, must be perpendicular. Okay, well, let's think about what we said over here. If they were parallel, then we would know that they were perpendicular also. We don't have any evidence anything's parallel here. Now, if two things were perpendicular, then we would know they're parallel. But we don't really have any evidence that it's two things that are perpendicular to. So what's the only two lines that are perpendicular? Well, the only real information we have is line V and line Y are perpendicular. You want to say the others, we just don't know. That might be true later, but right now we just don't know, so we don't want to jump. We don't jump to the end, okay? Consider, if two lines were perpendicular to the same line, then they are parallel to each other. Okay, what is the name of the theorem I just said? Two lines, we go back to the front, two lines that are perpendicular to the same line. Okay, that's the theorem called lines perpendicular to a transversal. Lines perpendicular to a transversal. Okay, draw an example of the theorem. So, two lines that are perpendicular to the same line. Line M, line N, and our transversal we'll call T. Okay, this is an example. Now, let's take a look at the same thing here. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. Okay, great. So, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular. See, what is the name of the theorem described on the left? If a transversal is perpendicular to one of two parallel lines, that's called the perpendicular transversal theorem. Okay, so perpendicular Transversal theorem. Okay. Why is the conclusion on the left wrong? Right? They see this picture and they say, oh, that one must be the same as Z. Really? How do we know that? Okay. Well, again, we ask ourselves, how would we know that? Well, let's go backwards here. We would know that this, and that would be the same. Okay? Take a look. If transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other one. But truthfully, we don't know that there's a parallel. Okay? So why is the conclusion that y and z are parallel? We actually don't know if this is perpendicular. We don't know if line y is perpendicular to line x. If we did know, then we can say, sure, y and z are parallel. We just kind of skipped a step. And we want to know, we think we know, we think we want to know, but we just don't actually know. And that's the hard part of geometry. Just being able to separate the things we want to be true to things that somehow tell us we should be true, but they're not really true. All right, that's what we're working with. All right, good luck in this assignment. If you have any questions, ask me or another teacher.